IP addressing and all this thing, right? So I will start with router number 2 first and giving IP addressing scheme to this router. Right now, when you see this message, would you like to enter initial configuration dialog? What is the meaning of this? Would you like to enter initial configuration dialog?
Well, you want to create the password for the router.
This meaning that you don't have any configuration. Configuration is blank. Yes, you have to be configuration. When you see this message blank, there is no startup config file. So show startup config, because information is saved in a startup configuration file. And I will, this is global mode, host name is router number 2. I'm creating here the loopback interface, which is IP addressing scheme. Here I'm using first 2 octet is 10.1 inside one, and third is like this is 2. Third octet is according to the requirement. Gig 00 is facing R1. So gig 00 IP address 10.1, since it is facing R1, so 1 and 2. Subnet mask class C, no shutdown. And for routing, I am using OSPF. So within a site, routing protocol is OSPF. So advertise network, first 2 octet is 10.1, third and fourth could be anything. Match first 2 octet, third and fourth could be anything, and all this link is the member of area 0. So then go to router number 1. So in R1 you have gig/1 and gig 00. Gig 00 is your public link, so it is using the structure is 192.169 13:1. So go to router number 1 and so host name R1 gig 0/1 IP address, this is 10.1 12.1. so only this link is the member of OSPF. So I'm saying within interface, I'm saying area 0. At interface level, running the OSPF, you can see neighborship is up. Gig 00 is the link facing towards public internet, and IP schema is 13:1. Subnet mask is this one. To communicate with the internet, I also need a default route here. If you're not using BGP, then default route is the key. With the next stop is 13.3, because on the other side next stop will be this one. Okay, so far if you look for within the site, you have the full reachability. That means if I look for my routing protocol, I am learning the OSPF LAN segment, show IP route, this one 10.1 2.2 via 12.2. so I have full reachability to this IP address. Similarly, configure your site number.
Please hold on, I'm just sketch the topology so I can follow.
Okay, yeah, so topology will be like this.
Yeah, the recording is on.
Recording is on. Let me pause for the meanwhile. So far I have configured site 1 with their private IP addressing, and the link facing towards ISP is configured with public IP. Default route is configured. And then now I'm configuring site number 2, which is 4 and 5. So gig 1/1 gig 00, 4 and 5. Host name R4, interface gig/1, IP address 10.2. Yes.
So this side we 10.2.12. This side.
Yeah.
For site 1.
On site 1 10.1, in site number 2 10.2 is common, and this is 45.4.
No. Hold on. Site 1 between R1 and R2.
10.1 is common. Third and fourth according
So
to
I'm
your,
saying between R1 and R2 be 10.1.12.
yes, 10.1 12. Yeah.
1 there, 2 here.
Yeah. This is the scheme.
So simple in this one.
Yeah.
Your life notes.
So see, this type of planning is also later on when you troubleshooting something, you know that okay, IP addressing scheme is like this, so it's easy to troubleshoot. That's why planning is required. So this link is the member of OSPF, the link facing towards R5. The link which is going to ISP, which is gig/0 in R4, and IP addressing this one 192.169. The link is going to 3 cities 34.4. To communicate with internet, again I need IP route pointing to next stop IP 192.169, then 34.3. So then go to R5 and configure R5 with the required minimum configuration IP address and OSPF. Here I am using loopback interface to simulating LAN segment, which is 10.2 5.5 with I can use host route, no problem. This is the uplink connecting to edge router in this topology. 10.2 45.5.
So have you resumed the recording?
Yeah, yes. Recording is
Okay.
continue. And now shut down. This one is the host name R5 in this topology, and this is running again OSPF advertising network 10.2. First two octet is common, third and fourth could be anything, and area is 0, all the common area. Yeah. Okay, so that means if I go for R4 show IP route, R4 can communicate with so far it's not show IP OSPF because the other link is in the shutdown state. I can only see one route in the routing table. This one is not up, so I need need no shutdown command. 0/1 no shutdown. So earlier it was in admin down. That means no shutdown command is required. Because now SPF loading is done, show IP route, and now if you ping to, because it is learning, where is that IP? I said show IP route. I'm learning this IP address. So this is the router 5 LAN segment, which is using 10.2.5.5, but so far it do not have any communication with 10.1 and 2.2. No communication at all, even though it has a default route. So sending outgoing traffic but not getting any incoming traffic.
It's gonna reach 192.169.3.
Yeah.
Okay, and out 10.1.2.2 can also reach the same IP. But
10.2.2 can reach up to this gateway but cannot communicate with so far this. But router 3 is not configured yet. Let me configure this 3. It will not configure without netting solution, right? Because public IP is not allowed. Public IP is not routable in the public backbone. So this link is facing to R1 and this link is facing to R4. So gig 00 and gig 0/1. So gig 00 gig/1. This is the ISP router. CPU hog. Host name R3 gig 00 shutdown. IP address, which is 192.169. 13.3 is 13.3. Okay, now shutdown. Gig 0/1. IP address 192.169. What should be third octet? 34.3. There's also one more link, which is gig/2. Shut down. This is going to R6, which is 36. And ISP configuration is done. This is only IP addressing configuration here to simulate ISP cloud. Okay, so now if I see here router 1 perspective, so router 2 perspective, router 2 can only ping to its gateway, which is 10.1 12.1. Can he ping to 192.169.13:1? So it has no. What is the reason for this? So far, because router 2 have no idea how to send traffic to this destination, because route is not in the routing table. So it is originating from this source, from this router, checking the routing table, because destination is not in the table, it is dropped here. So what I need, including the SPF, I also need to be originate default route. So default information originate. So once it is originating, go back to router number 2, and since it has now, it is learning the default route from the OSPF. So 1913 colon 1 reachability, but 3 is not reachable, so you need, because of NAT, you need NAT. So same requirement in the R4 side. You need to be originate default route within the OSPF. Router OSPF 1 default information originate. So 5 can now ping to the link going out, which is 6934.4, but it will not able to ping .3 because do not know how to send traffic back to this source IP. So now my goal is that if your edge router, this source IP can communicate with this one, so then you can build a GRE tunnel or any kind of tunnel. So edge to edge reachability is required through the public network. So if I go to R1, and since I have a default route here, if I ping 192.169.34.4, not 3 is reachable, but 34.4, so I have reachability. So my source IP is the 13:1, destination is 34.4. so now I'm ready to build tunnel on the edge router. So interface tunnel, you can give any number, so tunnel 1. So default mode here in the Cisco router inside the tunnel is GRE, so GRE over IP default mode. That means this command is not required. Tunnel mode GRE over IP, this command is by default enable. GRE over IP. So then I need to be specify who is my tunnel source, which is 192 my public IP 13:1, and my the tunnel destination is 192.169.34.4. My tunnel private IP address is 10 dot, let's say what I will use 1, suppose 10.1, first two octet is common. Tunnel between 1 and 4, that is 14, say 14:1. The subnet mask is, there is a point to point link, so I need to be match this IP subnet on the other side. This is done. Now on the other side, which is on R4, say interface tunnel number 1. My tunnel source is 192.169.34.4, and my tunnel destination will be 192.169.13:1. My private IP address for the tunnel is 10.1, it should be match, then 14.4, and this link is the member of OSPF, area 0. Now everything is fine, it will build OSPF neighborship over this GRE tunnel.
But if you do the OSPF for that IP on the other side, the 10.0.
Yeah, we have done, because here on, yeah, not there. So again I have to be use, go to R1, go to your interface tunnel 1, and this is also the member of SPF area 0. I can see there is a neighborship is discovered on this tunnel 1 interface. Result is that if I go to R4, so I'm learning the LAN segment of the site 1 via tunnel interface, this IP. So next hop is tunnel interface, because now routing is there. That means if I go to 5, so 5 is also learning this IP.
That's all. That's
Okay, so and in these examples, no IP domain lookup. So if I do the trace route to 10.1.2.2, so first hop will be 4. Okay, the second hop is your GRE. Next hop 14:1, which is router 1 IP address, and this one is the final hop. The traffic is going through the GRE tunnel.
Yeah.
And here if I look for R1, show IP interface tunnel 1, these are the IP parameter for this tunnel. Okay, so MTU is now 1476 24. Trace route from R1 for R4.
From R5.
Yeah. First hop is, second hop is 14.1, third hop is 10.1.12.2. So 1, and here we'll see that first of all you can see this MTU header is automatically subtracted because it is a 24 byte overhead, 4 byte GRE, and the next thing is, okay, only this thing on the tunnel, and show interface tunnel interface. This one is using tunnel protocol. Tunnel source is this, tunnel destination is this one. Okay, so this is giving the indication that tunnel is up, and you have now reachability end to end over the public network. So now next what I want to secure.
So that is GRE.
This is GRE. Done. Simple point to point tunnel mechanism. So you're connecting a layer 3 link over this public network. Now secure IP traffic over this GRE tunnels by configuring.
Between R1 to R6.
There is no tunnel between R1 and R6. Okay.
Second branch.
This is the second branch. So because it is a point to point tunnel, you have to be now create one more tunnel towards R6. Same approach. But here GRE and then ipsec. So ipsec is again on your edge router. So these are your tunnel endpoint, R1 and R4. So all traffic is coming unencrypted here. This router will do the encryption, encrypting payload, sending in the over the tunnel. This will do de-encryption, send traffic to your branch side. And for the ipsec now between 1 and 4, first of all you will create phase 1 proposal or phase 1 parameter. This is with the help of crypto ISA-Kemp policy and the name of the policy. So here I will using the authentication method is pre-shared key. So authentication method can be your pre-shared and RSA signature. here we are using pre-shared. Hashing is based on MD5 or SHA. So let's say I'm using here simple SHA, and these parameters must match. If one side, if you are using SHA with key size 256, other side you must have these ciphers. These are known as a cipher. So cipher is exchanged initially with the help of security association. So authentication, hashing, encryption. Encryption I can use a different standard. Recommended one is advanced encryption standard, AES. It is also using different key size, so I'm using simple AES. And then by default life is 24 hour, so that is, which is 86,400 seconds. Then what you need, so haggle, right? Hashing, authentication, live, group. So Diffie-Hellman group. This is exchanging the key in a secure manner by using this algorithm, any group number.
So the highest order in this case is 24.
Yeah, higher is better, but that need also more CPU. So here I'm using group number 2. Okay, so this is your phase 1 parameter, and now in order to make this phase 1 complete, you have to be set key password, because right now we are not mentioning what is the key. So this is with the help of crypto ipsec key cisco for the address remote peer. In this case 192.169, no, public IP. Yes, right now this is your building a tunnel, ipsec tunnel. So your peer is
the ipsec tunnel will be different from the GRE tunnel.
Yeah.
Okay.
So right now this is the phase 1. Your payload is going through the GRE tunnel. Okay. Then this is your phase 1 parameter. Now you have a phase 2 parameter. This is with the help of crypto ipsec transform set. You're giving the name of the transform set, and then you're sending the proposal or ciphers. So you have two possible protocol, AH and ESP, where ESP is recommended. ESP support hashing also and encryption also. ESP support hashing. So this is encryption standard, that one is the hashing. So I will say I'm using this HMAC, SHA HMAC for authentication, for hashing, and ESP AES for encryption. Over here,
can you change the other, like in this case you've used the hashing before you've done the...
Yeah, you can change the order, no problem. But these parameters must match on the other side also. Then you have a two mode of operation here, transport mode and tunnel mode. The default is tunnel. I'm keeping it tunnel. So transport is only payload, encapsulation, encryption. This is the entire datagram encapsulation. So original IP header is also encrypted. Then you are mapping this transform set within a ipsec profile. Crypto ipsec profile name is ABC. Then you will say set transform set, name of the transform set is ABC. So far show run. So these parameter is exchanged with the help of IKE protocol. IKE.
The set transform command, where exactly is it?
Transform set. this is exchanging phase 2 sorry key this is exchanging phase 2 parameter.
Okay.
So that is exchanging phase 1 parameter. In this case it is authenticating source peer. So default mode is main mode. So step number 1, you're creating a ipsec policy.
That's over the physical public network.
Yeah, so you're using all these parameter, and these parameter must be same on the other side.
The phase 2 will also be exchanged over the physical public network.
Phase
The phase 2 information will also be exchanged over the same public link.
yeah, and then you have this transform set. Transform set is mapped under this ipsec profile.
Okay.
So go for other side, which is R4, and this is now so crypto ipsec policy 1 authentication. You're using pre-shared group, you are using 2 hashing, you are using SHA encryption, you are using AES. Life is default, which is
Once
24
it's on
hour.
one side, you don't need to
Yeah.
define it on the other side.
Yeah,
But I think on the
because
other
default
side,
is 24 hours. I'm not defining on the other
on the
side.
other side we didn't define. He showed that is 24 hours.
Here.
We issue a command.
See, these are only encryption, authentication, group. Even it is not disclosing your encrypt hashing. Hashing SHA is default. That means default parameter is not displayed. So go for R4 and then crypto ipsec key Cisco address is peer IP 13 colon 1. Then create crypto ipsec transform set. Name is ABC. Now here parameter must match, which is first ESP. You have AES, then ESP SHA with HMAC, and mode is tunnel, and then create crypto. Everything is mapped within a ipsec profile. Crypto ipsec profile name is ABC, and set transform set ABC. Okay, so now it's time to attach this transform set in the GRE, so that when the traffic is passing over the GRE it will be encrypted. So interface tunnel 1, this command is going to be map. So tunnel protection ipsec profile, and the profile name is ABC, which is in case sensitive. This will terminate. So ipsec is on, and soon what will happen, your tunnel will be down. So OSPF is now down because parameter is not matched.
On the other side.
Yeah, so this is your GRE protocol number is 47. Show show interface tunnel 1. Okay, so it says line protocol is down. Show crypto ipsec security association. So right now this is the ipsec UDP port number 500. Okay, so you have this local address and mask port information. This is your remote IP address, update mask, GRE. You can see the session is not established here because the line protocol is down for the MTU for this GRE. So go to other side 1 and map your tunnel profile under this tunnel. So tunnel protection ipsec profile, the name is ABC. If everything is fine, once again it will, okay, the line protocol is up for this tunnel, and since tunnel mode is also encrypting your original show crypto ipsec security association. So you can see there is encryption, de-encryption is going on. This is your OSPF packet is encrypted because OSPF sending message. So OSPF packet is encrypted. Every 10 seconds you are sending this.
Encryption. So why was the tunnel down at first? When you finished configuring the same parameters on R4 as you did for R1, why didn't the tunnel?
Yeah, because it was not mapped in the tunnel interface.
On the R4.
Because this command was not applied yet.
Which this had been applied at R1 but not R4.
Yeah.
Tunnel protection and
Earlier what I did, I mapped this command on the R4 first because this command was not there in the R1. Tunnel is down. So then I came back to R1, mapping this command. It is negotiating parameter is match, and then once again tunnel is up.
Okay.
Security association is done, traffic is encrypting, and if I go for 2 here and send traffic to 10 dot, which is 2 dot to 5.5, the repeat address is, let's say 100. I'm sending 100 packet, and on R1 if you look for this, so all this traffic packet is encrypted, encapsulation, de-encapsulations. So this is your IPsec tunnel with GRE. You have also the command show crypto ipsec security association. This one, the destination is this, source is this, and state is active. Status is active, that means everything is fine. This is ipsec phase 1. This one is ipsec phase 2 for IPsec tunnel, crypto IPsec security association. MTU is once again going to 1438 because of the additional overhead of ESP header. Okay.
So just to get this clear, it means when you are employing something.
So this is your edge. Okay. Create access list. Allow your private IP is 10.1 from this side. This is my ACL. Destination is any, sorry, permit IP. Protocol is IP. Okay. Then IP NAT inside source list number 100 interface. In this case it will be gig 00 on R1, gig 00, and since it is a pad it will be overload. Okay.
So this is got a topology.
Yeah.
R1
link going to R3 gig 0/0. This is the public link. This is IP NAT outside. It should be configured with IP NAT outside. It will take some time to process this.
The G00 overload, what does the overload?
Overload meaning this is allow you to carry many IP translation with single public IP.
Okay.
So then link facing inside gig 0/1, this will be IP NAT inside. IP NAT inside. So now user belongs to your this side, will able to communicate. And if I go to router number 2 and ping 2, let us assume that I have one, go to R3 and create one loopback just for testing purpose. Loopback 0, IP address is 888. It is directly connected with this router. Okay, so go to router number 2, because netting is there, it should able to ping 888. 888 is reachable. So router 1 is doing translation, show IP NAT, translation. Netting is done. If I go to, let us assume that if I go to R4, can R4 can ping 888?
The routes on alpha for now. Okay, alpha should not be able to ping 888.
It will not able to ping 888.
No, that's translation.
Yes.
What?
So go to R5 and ping here. Ping 88888. So it has no reachability.
So we have to implement NAT on R4 to if it is designed R5.
Yes. And what if I configure NAT on tunnel interface?
If it's on the tunnel interface and there's a tunnel
Then
between.
alpha should be able to reach because it's you can learn the
R5 also have a connectivity up to this.
Yes.
R5 can ping 10.1.14.1.
Yes.
This is the tunnel private IP.
Yes.
And let me do this on R1. So I will say this is the HQ.
Would that not interfere with the ipsec configuration?
Yes, it is. Let me check this. This is the testing. IP NAT inside. Okay,
with that tunnel itself.
this is IP NAT inside. IP NAT inside is there.
I think in this case, if you want
So traffic will come from
insights
5.
to access the internet, you have to configure the direct mask to the R3. I mean the direct NAT translation with the R3 as well.
No, see
Because
R5 sending traffic up to this HQ.
I said R3 is not for you.
R3 is the ISP
You
router.
do the NAT translation on R4.
Yes.
You can do the NAT translation on
outside.
R4.
Then you have your access for your site. If you want to branch,
Yeah,
you
so
have
this
to
is for
do
local. That is the example is user connected with that branch is accessing internet via local ISP.
Yeah, so for now, headquarters, you have internet access. For branch site, no internet.
Yeah, so branch side do not have internet
Hmm.
connection.
But over the tunnel,
But here, if I go back to this and pinging 888, it is not communication. It will not provide any communication
let's try over
because
the
traffic is, yeah, okay. I need to be allow this traffic
tunnel.
because ACL says access list 100, permit IP also allow 10.2.0.0 and destination is any. Go to R5.
Okay, so you did all this on R1.
But once you are applying it on the tunnel IP, on the tunnel, then
IP NAT inside.
then we have to allow the tunnel IP
Tunnel IP is also allowed because 10.1 ACL is here.
Can you ping A.8 and let's see the path taken to the A.8? Not that we use the tunnel route from the R5. So
Trace route 8888. It's going to first hop
once fiber.
and then it is drop.
Yeah, so it's not passing through the tunnel.
Yeah.
So it's not look at the access list on the R1 in the permit.
It is.
The access list on our
Yeah.
Because
Access list on R1 is there. Show access list.
yes, but we are we are implementing the NAT on the tunnel
NAT inside interface.
on the tunnel, right?
Yeah.
Okay, but what's the tunnel IP?
14 dots.
Tunnel IP is 10.1, first to octet. First to octet is 10.1. Tunnel IP.
10.1.14.
Show run interface tunnel 1. This is the tunnel
Okay.
IP address.
Okay.
Allowed. Okay. And what source? This will not work here. IP NAT inside because traffic is not passing over this. So I have to configure netting on R4 to provide access to. Okay, so here go to interface tunnel 1, say no IP NAT inside. Go to router 4. Okay, so access list 100, permit IP 10.2, destination is any, IP NAT inside source list 100, interface gig 00. Okay, gig 00 and overload. Gig 00 is IP NAT outside. Is let me check this. Recording is on. Yeah, okay.
Necessary requirements, you reach internet for you to have your tunnel. If you don't
So with this configuration, HQ can also access internet, branch can also access internet. When the HQ branch is communicating with private IP, that traffic is encrypted with ipsec tunnel. Gig 0/1. This will be IP NAT inside. So that means if I go to R5 and ping to 888, it should work now. Pinging to 888. R4 is doing translation. Show IP NAT translation. But the question is now, can R5 can ping R2?
Yeah.
Ping 10.1.2.2. Yes, so it is pinging because traffic is going through the GRE tunnel, and GRE tunnel is not playing with NAT.
First of all, for the GRE or for the GRE, we already needed connection to our ISP, direct connection to our ISP on
Yeah.
our two airdroppers. Now we've built that tunnel between our headquarters and our branch.